one, Dr. Natasha Smith will be introducing our team.
All right, good morning. It's my pleasure to introduce Kyle Wilkins, Paul Opers, and Matt Snyder. And these guys are going to talk to you about a project that they're very passionate about. And who knows, in a couple years, maybe you might see this on a toy store shelf. So take it away, guys.
Thank you, Dr. Smith. All right, so for this project, we're going to start by talking about the game pinball. We're going to talk about designing a multiplayer game based off of the concept of pinball. And we're going to go through the objective of our game, the design of it, and the building of our game, and where we're going to go at the conclusion of this project. So pinball's a pretty simple, straightforward game. You have a slanted table, you have a ball that you hit with two flippers, and you have some targets that you're trying to hit with the ball. And between the flippers, you have a drain. And when the ball goes between the drain, somewhere between 3 to 5 times, the game ends. And every table has its own unique characteristics, as can be seen here with whirlwind and taxi. Now, technology has remarkably improved the game of pinball over the years, and multiplayer pinball games have been attempted before. There have been 2 tables lined up back to back. There have been tables that have a time trial method where the score as many points you can. And there are tables where one person controls the obstacles while another controls the ball. But no one has ever attempted what we're trying to do. And what we're wanting to change about the game of pinball starts with taking it from a one-person game to a multi-person game that can include up to 4 people. We also want the table to be a lot more portable. We want to be a lot smaller and easier to move around. And we also want it to be a lot less expensive. On average, a pinball table can cost somewhere around $10,000, and we want it to be a lot cheaper. And the gameplay can also be very complicated. The gameplay can be very complicated if you're not familiar with a particular table. You could be hitting the ball around randomly with no real sense of purpose of what you're doing.
Okay, so the objective of our game, the objective of our project is to make 4-player pinball game. We want this game to be cheap, portable, and very enjoyable. So this is a concept model that we made in SolidWorks of our game. And you see we have the flippers, the button, and the pinball, just like a normal pinball game. And our table is roughly about 18 by 18 inches wide. So our project broke up into 4 subsystems: the gameplay, the table, the mechanisms, and the electronics. So we'll start off with gameplay, which is broken up into the style and rules. So for style, basically we want to ask the question, how do we make this game as enjoyable as the cheesy advertisement commercials? So to do this, we want to make the game simple, easy to learn, easy to use, so that new players and veteran players can play with the same competitiveness. For enjoyableness, we want the game to have a good social aspect to it. We want it to be competitive, and we want the game to be fast-paced. The rules for our game are quite simple. You have a 5 by 5 grid of squares in the center of the table, and each player will have their own color: red, green, blue, and yellow. The goal of the game will be to roll your ball across the squares and get a 5 in a row of your color. And a secondary objective is to knock your ball into another person's drain, which will allow you to steal all of their color squares. So our next system is the table, and it's broken up between the surface and the base, and I'll talk about the layout and material.
Okay, so to get into the design for the layout of our surface, we decided to make this shape a square because we have to account for 4 people playing at the same time in a fair competitive game. And we also don't want the ball to get stuck constantly on the surface. So we know that somewhere on this square, we have to create some inclines to cause the ball to roll. But we don't want to make those inclines too steep, because then the ball can start ramping off corners in the table and cause noise or maybe even damage the surface. So we have a small diagram over here that shows the basic outlay of our surface. And you can see each set of flippers is in its own corner, and we're planning on bending the surface along the dotted lines shown in there. And then the section in the middle will actually be flat, and that's where we will plan on positioning our 5 by 5 grid of squares that Matt just talked about. All right, so there were a lot of other considerations that we had to take into account. First being, we want to design the shape so that the players are comfortable while they're playing, and they're not pushing buttons in at awkward angles or positions. Second, we want to create room behind the flippers so players can lose the ball. and for room for a launcher that they can use to send the ball back up into the middle of the table to continue playing. We also, this is probably our most important consideration, is that we don't want to allow one player to win the game from just one shot straight across one row of squares. And to fix this, we designed and created a plexiglass lid with pegs that you can see here that will hang down from the lid and get in the way of the path of the ball as it rolls across the table. We also want our surface to be removable so that if you have to do maintenance on any internal components on the table, that you can remove the surface and easily do that. All right, so whatever material we use for this surface, it's got to be thin enough that we can bend it ourselves, but not so thin that it's going to sag in the middle and cause the ball to get stuck. So this material that we chose, it had to meet three main criteria. First of all, it had to allow infrared transmission for our infrared sensors, which we'll talk about later in the electronics section. We also had to be able to drill holes in the material for our flippers, and last, we had to be able to bend the material manually, because to have it professionally bent for us would have cost around $500, and that is quite a bit of money for a college student to spend on a project. So we went with our own solution, and it's from the table, it's going to include some glass and some aluminum or steel. So here's our solution. It includes aluminum and glass, and to manufacture the part, we had a aluminum sheet donated by C&L Sheet Metal, and we took it up to the Applied Engineering Center here on campus. And we had the water jet machine cut out the outside edges along with the square holes in the middle. And then the CNC machine milled out some 1 millimeter deep pockets around the edges of these square holes. And that's where we were planning on putting some 1 millimeter thick glass microscope slides into the pockets to act as our windows for the squares. So then we brought it to the mill, and we milled out some grooves on the underside of the surface to make it easier to bend. We bent the part, we inserted our glass slides into the pockets, and then we finished it off with a black vinyl sticker to make it look better and to hold the glass slides in place so they don't fall out. And then we have some more pictures of us working at the Applied Engineering Center. On the left, Matt and I are bending our surface over a frame that we created to create our inclines. Up at the top right, Kyle and I are inserting our glass slides into the pockets that we milled around the square holes, and then the bottom right is the final assembled surface with the glass, the sticker, and even the flippers inserted into the holes we created. So now I'm going to let Kyle talk to you about the design and fabrication of the base of the table.
So for the base of the table, there were several requirements that we had to meet. First, the base had to have enough area to hold the electronics, which I will discuss about here in a second. And second, it had to be tall enough that there was enough room for the lid and the pegs hanging down from the lid to almost touch the surface but not completely touch it. And we chose to make this base out of wood because it's an easy material to work with, and we all have experience working with it. So for the electronics, there were two shelves. We had to have two shelves for them. The first shelf had to contain the LEDs and the sensors to be placed right underneath the square holes. And the bottom shelf had to have the microcontroller and the power supplies. And we chose to use pegboard for this. And we also created adjustable supports for the table. So if we're not playing on a level surface, the screws underneath can be adjusted up or down to make the playing surface level. And here's some pictures of us creating the base. On the left, Paul using a table saw to make the wooden parts. On the top right, the wooden parts are being fitted around the surface to make sure they're at the right dimensions. And on the bottom right, the completed base, the completed surface, and the lid are shown. So now I'm going to turn it over to Paul for the mechanism subsystem, which consists mainly of the flipper system and launcher.
All right, so our first mechanism is our flipper system, and it consists of our 3D printed flippers in the shaft, the solenoid, and the linkages inside the solenoid, and also the buttons. And then the launcher consists of the launcher shaft, the spring which powers it, and then the guide channels which center the ball over the launcher. And the launchers are going to be positioned just behind the flippers, right about where that circle is. So when we were designing our flipper mechanism, we had to make a decision, are we going to power it electrically or mechanically? And we knew from the beginning of the semester that we wanted to limit the motion of the flipper to one single click, even if you were to hold the button in. Because if you allow players to hold the button in and hold that flipper in an up position and catch the ball, you're slowing down a multiplayer game, which is not a good thing to do. You're also making it really easy to make the desired shot every time, so we don't want to make it too easy to win. And we tried to do this mechanically, but we couldn't come up with a very good way to do that. So we found an electrical solution that contained a solenoid and linkage combination with programming code to help us get this motion. All right, so here's our solution. We had to purchase all the materials listed on the left over here, and we used a lot of machines in the Applied Engineering Center to make this mechanism. So using those machines, we machined ourselves the 8 plunger rods and the linkages shown in the picture up here. And the bolt acts as the shaft for the flipper. The nuts hold the linkage in place as the mechanism moves. And then the plastic flange bearing serves to protect the hole in the surface from being worn away after so many uses. And so we have a short animation here in the bottom right to show you exactly how that works. For those of you who don't know what a solenoid is, it's basically a coil of electric wire. And when you power it, it basically becomes an electromagnet. It's going to pull the plunger rod in very quickly, and that's what will give you the flicking motion of your flipper. And then there will be a spring inserted between the solenoid and the linkage to push the mechanism back out to the original position after the solenoid disengages. All right, so this brings us to our last subsystem, which is the electronics. And the electronics consist of the microcontroller, the sensors, the LEDs, and the power supply. I'm going to let Matt talk to you about this subsystem.
Okay, so we're going to start off with the microcontroller, and the microcontroller is the brain of our game, so it controls all the rules and conditions. And it is basically a miniature computer, and it has a memory unit, processor, and a bunch of programmable input output. So we decided to use Arduino because we had access to one that we could practice with, and it's very user-friendly. And due to our lack of electrical experience, we needed something that was easy to use. We decided to go with 2 megas because we needed enough input-output pins for 25 sensors and 25 LEDs. So for our sensors, we looked at ultrasonic sensors, which detect sound, but we decided that these couldn't work because it may not detect the sound of the ball moving across the surface at all times. We looked at Hall effect magnetic sensors, but this required a permanently magnetized ball. Pressure sensors were very ideal for detecting contact with the ball, but they would interfere with the LEDs on the surface, so we cannot use them on the surface. We could use them on the flipper. For the ambient light sensors, these could be a problem because the LEDs can come on, so they interfere with the signal, and potentially just cause faulty reading of the sensors. Laser sensors looked at, these would be mounted on the walls, and the ball would come in contact with the walls, so this could damage the sensors, and it's also a no. Finally, we looked at infrared sensors, and these would be very easy to put underneath the table with the LEDs, and they would also be able to detect the ball at fast moving speeds. So for our solution, we used a Sharp IR sensor, and these emit and receive infrared signals. And they're small and compact, and in order to use them with the Arduino and run all 24 of them, we'd get a Blueberry Day expander shield, which would give us 24 extra analog pins to go on the Arduino. And this would also make the code a lot easier. And for the pressure sensors on the flippers, to detect the ball so that the game would know when a player hit the ball or not, we would have a pressure sensor wrapped around the flipper so that no matter where the ball hit the flipper, it would know that the ball hit the flipper. For LEDs, we got simple RGB LEDs. So this gave us our 3 primary colors, red, green, and blue. For our 4th color, it would be a combination of red and green to get yellow. And in order to run all of them, we have to have 3 24-channel drivers. So each driver would control a separate color, red, green, or blue. And then to get yellow, we would make a combination of these 2 drivers to get the 4th color. So in order to power all this, we need 2 different power supplies. The power supply for the sensors and LEDs would be a 5-volt 2-amp power supply. And the power supply for the solenoids needs to be a lot stronger. So we chose to get a 48-volt 7-amp power supply. And we chose to use switching DC power supplies because they are light and compact and going to help a lot of weight to the game.
So at the current stage, we have our table assembled as well as our mechanisms are working. Most of our electronics are working, our sensors are working by themselves, and we have a trial code to work for our LEDs and sensors. However, we still need to fully assemble our electronics, including our pressure sensors and our infrared sensors and our LEDs. And we also need to debug our code and make it work exactly how we want it to. But we do have a short video for you all to show you our capabilities of the table at the current stage. And in this video, you'll see 4 people hitting the ball around with the flippers and using the launchers. So you will see that the mechanical portions of the project are completed, and to fully complete the project, all we need to do is get the electronics working properly. right, so to continue to try to more fully meet our objective, first of all, we need to get all of our mechanisms and our electronics working in unison. And then after we do this, we need to send it out for test playing to see if people actually think it's as enjoyable as we hope it is. And to improve the game after we're done with it, we can reprogram our microcontroller to call for different winning conditions or different game modes. We can constantly redesign it to cost less and weigh less. And we might even incorporate some cool features like removable pegs for the lid, or even maybe a multi-level playing surface. Pretty much anything we want to do. So in conclusion, we successfully designed and mostly fabricated a 4-player pinball-style game. It meets our portability objective because you can carry it out to your car and you can store it in your car. You can play it on a table with 4 people. It meets our cost objective because it's less than 10% of a regular pinball machine. However, we're still waiting to see if it meets our enjoyableness objective because obviously we have not yet had the ability to have people test play the finished product. So before we ask for questions, we want to acknowledge many people that helped us throughout this semester for this project. A special thanks to our advisor, Dr. Smith, for her wonderful guidance and advice throughout the entire semester, to Mr. Justin Amos for all the help that he gave us up at the Applied Engineering Center for manufacturing most of our parts, to C&L Sheet Metal for supplying the aluminum, and to many of the engineering faculty for their advice and for sitting in on our practice runs throughout the semester, to our classmates, Charlie and Richard, for their electrical and programming advice, as well as Brandon Dilger, to Donna Moore for keeping us on track and for just being awesome, and also to our families for their support, and a special thanks to my dad for all the help he gave me throughout the semester. All right, so are there any questions?
All right, questions?
Could you state roughly how much it weighs? And also, are you guys planning on figuring it so like 2 people can play and 3, or does it always have to be 4?
It doesn't have to be 4. We did plan on creating some wedges, some triangular wedges that you can insert onto opposite sides of the table to block 2 sides of the table. I mean, it is a square, so you can't make it symmetrical for 3 players, but we can make it a 4 or 2-player game if we wanted to. Oh, the weight? Well, it was heavy enough to cut Matt's finger yesterday as he was carrying it over here. So, I mean, it's easy enough to bring, you know, from your house to your car. I would say it's probably around 25 to 30 pounds.
So with regard to lighting up the light with a specific color, does your algorithm just use the last flipper touched to decide which color it's going to light up?
Yes, it does. So whenever a flipper gets hit and presses the next ball, it basically will switch to that player's color. So, and then from there, it will just line up the squares according to that color until the flippers get hit.
And then can a second player steal a square so they're changing colors all throughout the game?
Yeah, when the ball goes between the drain, then there will be a sensor on the drain that will activate, and whoever the last person to touch the ball was, those squares all become that person's squares.
Yeah, and the squares are not permanently owned. So if red has a square and blue hits it over the same square, it will turn blue. So you can kind of plan out where your next shot's going to be according to maybe who's close to winning, or you know where you're close to winning. So you can direct your shot towards different parts of the table.
And finally, do you have a name for this game?
We don't. I think that was kind of the last thing that we didn't want to butcher after doing so much work on this project is giving it a really kind of stupid name. So we just kind of left it out in the open, and I think we're probably going to come up with a name after we graduate.
Thanks.
Other questions?
Is there a limit to how many squares a player can get per time the ball comes from their station?
No, there's not. So basically, you could hit the ball and hit as many squares as you wanted to. So, but of course, if you get 5 in a row, you're going to win the game.
So yeah, I mean, technically a good way to play the game is if you can hit the ball into pegs and get it to bounce back to your station every time and just keep getting squares. That would be a good way to play the game if you can do it, but it'd be difficult.
I was just curious if you had taken into consideration maybe the wear on the pins from being in contact with the ball so frequently, and what your anticipations were for peg strength.
I mean, we were going to use bolts for the pegs originally, but I think they would have kind of looked tacky in the plexiglass surface. So to give it kind of a cooler look to it, we went with plexiglass. But I don't think, because they're not too long, so I think they'll hold up pretty long. I mean, and it's not that hard to put new ones in because the holes still will be the same size. And you can just tap them out and then saw off some new pegs and just tap them in.
Did you have a mechanism to keep an opponent from tilting the table when you're about to win?
No, we kind of are going to rely on the other three people playing the game to, kind of as an intimidation factor of if you do this, nobody else is going to like it, so don't do it. But I mean, we could technically, to improve the game, yeah, we could implement something like that to keep people from tilting the game. That would be a good idea.
They'll be automatically disqualified.
From our experience with the game, though, it's extremely complicated to tilt the game because it is like 2 feet in the width. So we have had experience with it. It's not very easy to get the ball to move when it gets up there. So.
Do you guys intend to make this? Do you see it as a tabletop model, or do you intend to attach legs of some sort to be a freestanding unit? And also, do you see it more as a game to use at home, or more of like an arcade setting where you come in and play in a public location?
Yeah, we definitely tend to keep it with, just how it is, just the regular small supports, because we want people to bring it to other people's houses and play it with, a group of friends. We want this to be a game that when you have, a party that you think of, let's play this game, because pinball's not that type of game right now. And so we wanted it to be a game that you could store in your car, bring to separate places, and it wouldn't take up too much space to keep in, either your car or in the house. So I think we're going to keep it. I think we're going to keep it how it is, just because you can put it on the table pretty much, or on the ground if you want to, and play it pretty easily.
It could certainly be an arcade style game, but one of the main ideas we had with this game was to take pinball out of the arcade and into somebody's home.
All right, this is kind of a simple question, but how does the game start?
All right, so basically to start the game, wherever you win, the ball's going to be in someone's pocket. So basically it's going to start up, you're going to pick someone, 4 people, and go, okay. So
And
who wants to play?
when that does happen, does that not count for their squares when they launch it, or does it?
It will, so it'll just start out with, okay.
Not from the launcher. Yeah, okay, so there will be a random person to launch the ball onto the middle of the table, but any squares that the ball rolls over after the launcher after it's launched with the launcher will not get any squares. It's only from the flippers that you'll light up any of the squares in the middle.
All right, any other questions? Let's give them a hand.